All right, guys, here we go with the last or second video for U7L7. I wanted to start just by going to page 3 where you have these examples worked out. Just wanted to point out, in this case, they're doing just a particular solution. Okay, there's an extension of the question that says solve this on the interval 0 to 2 pi, not including 2 pi. So they have these 4 answers. All right. I don't know why that didn't get copied over here. In this one, there's also an extra in the key. It says to find all solutions. Sorry, I take that back, but the answers are just solutions between 0 and 360, and they're in degrees. Okay, so what I did, I took this 205.44 degrees. I subtracted, or I said that that's equal to negative 154.56 degrees, and then convert that to radians, which is 2.698. So that matches this general solution. Okay. The reason I convert it to a negative is because sine inverse is only going to find answers between negative pi over 2 and pi over 2. So actually, you know what? It would find, if you plug it in the calculator, it would find this answer over here, which I believe is, well, I guess it's, oh no, it's, well, it should be right here. Yeah, it's going to find this answer, guys. The calculator is going to give you this answer, okay? Which is the same thing as 334.56 degrees, right? So to get this answer, which the calculator will give if you do sine inverse, right? I took 334.56. I wrote it as negative 25.44. It's the same thing, right? Because if we go over 334.56, it's the same as that, negative 25. And then convert that answer to radians. Okay, so this is what the calculator is going to give you. And then you just kind of have to know there's another answer, right? The other place where this can happen is over here. And that angle, when converted to degrees, is this, all right? Yeah, and I guess what I should do too, now that I'm thinking about it, is say that this answer, this isn't going to give you anything, right? Because this is really asking, what angle has a sine that's equal to 6 plus square root of 106 over 10, right? Square root of 106 is bigger than 10. 6 plus 10 is bigger than, or it's like 16 point something. You can't have an angle that has a sine bigger than 1, okay? So I'm going to cross this out now, and you'll see it in the filled in notes, but this, just this portion, this has no solution, okay? This part will work, right? Because you're taking 6 minus something a little bit bigger than 10, so maybe like, you know, negative 3 point something. Negative 3 over 10 is, well, I'll tell you exactly, it's like this, or negative 3 point something, whatever this comes out to be. I guess, you know what, 6 minus something bigger, 10 is going to be like negative 0.42. So this answer will give you a value. In the calculator, if you're in radian mode, it'll give you this. You have to realize that, hey, there's another answer here. Okay? And that's why you get these 2 general solutions. All right? So please write me or any of your teachers if that is confusing. It is a little bit confusing, so if that's not totally crystal clear, don't worry about it, okay? It has to do with domain restrictions. All right, let's look at these new problems that we haven't done yet. So first one is, what is the sine of the cotan of, cotan inverse of x over 2? So remember, this part is really saying cotan of what is equal to x over 2, Okay, so we're saying, like, in other words, the cotan of some angle theta is x over 2. Then find the sine of theta. All right. So the way I would do this is set up a triangle, right? Well, if the cotan of theta is x over 2, the cotan inverse of theta is x over 2, this means the tan inverse of 2 over x. So the tan inverse of 2 over x, that's equal to the cotan inverse of x over 2. All right. So I want some angle that has a tangent of 2 over x. So here's my angle. Tangent's opposite over adjacent. So I'm going to fill this in and say, well, my opposite side's 2, my adjacent side's x, and therefore my hypotenuse is actually the square root of x squared plus 2 squared. Or really, maybe it's a little bit easier to say x squared plus 4. Okay? So what I'm doing is I'm setting this picture up. I've got some angle. Its tangent is 2 over x, which means its cotangent is x over 2, adjacent over opposite. And then this is a right triangle. Okay, that's important to put in. So I can get this by doing the Pythagorean theorem. This squared plus this squared has to equal this squared. So this thing is the square root of the sum of the squares. All right? Now, I want to find the sine of this. So the sine of this angle theta, well, that's equal to the opposite over the hypotenuse. So that's going to equal 2 over the square root of x squared plus 4. Okay? And that's our answer. So I guess, really, we don't need to say sine theta. We can just say answer, right? The sine of the cotan inverse of x over 2 is equal to 2 over the square root x squared plus 4. Okay? And I guess I'm going to write it here because it's important to know. And it should have been in the reading that you did, but it's always good to just kind of remind ourselves of it. So if we have sine inverse, that answer, sorry, I'm trying to figure out how to write this cleanly. So the sine inverse of anything will always give an answer between negative pi over 2 and pi over 2. Okay? Inclusive. So it includes those two endpoints. Cosine inverse of something is always going to give an answer between 0 and pi. Also inclusive. You can convert these to degrees if you want. So this would be negative 90 degrees. This is 90 degrees. This is 0 degrees. This is 180 degrees. Depends on what mode you're in. And the last one, tan inverse of something is always going to give an answer between negative pi over 2 and pi over 2, but it's exclusive. Exclusive. All right? So that means that negative pi over 2 and pi over 2 are not included. And hopefully we know that because the tangent there is undefined because there's no adjacent side. All right? So this is negative 90 degrees to 90 degrees, but exclusive. write no, or endpoints not included. Okay, that's probably enough talking on one page. So let's keep going. And let's just make sure that we remember that's our answer to this question. Okay, moving on. Find an equivalent expression for each of the following. Secant 3 theta in terms of function values of theta. So basically we want to go from 3 theta to theta. So in order to do that, I'm going to write this as, well, secant is the same as 1 over cosine. So that's the same thing as 1 over, I'm going to say cos 2 theta plus theta. And that's equal to 1 over, well, now if we do the cosine rule, this is, or the sum rule with cosine A plus B, this is cosine 2 theta, cosine theta, minus sine 2 theta, sine theta. Okay, so now we're almost there, but we still have these 2 theta parts here in this cosine 2 theta, and here in this sine 2 theta. So we got to make a substitution for those. So this is equal to, and we have some choices with the cosine theta, or the cosine 2 theta, excuse me. So I'm just going to go with cosine squared theta minus sine squared theta times cos theta. All right, and maybe it's overkill, but I'm just going to point out that this cosine 2 theta, we substituted that for. Okay. And then sine 2 theta is the same as minus, or is the same as 2 sine theta cosine squared theta. All right. And, well, you know what? Sorry, let me write it less confusing. Okay, so then it's a little bit clearer, and then I didn't make a mistake doubling up the cosine squareds. So sine 2 theta is 2 sine theta cosine theta. If we wanted to, we could combine the sines, right? But the problem doesn't really say to do that, so we could combine this sine theta and this sine theta and write this whole thing as 2 sine squared cosine squared. All right, but I'm going to leave it like that because that's what it says. The only thing that's bothering me a little bit is I don't like that this thing isn't extended over the whole denominator. All right, maybe. Yeah, let's clean this up a little bit. You guys can see my OCD or my type A coming through there. All right, so that's our answer for A. And then for part B, cosine cubed in terms of function values of x or 2x raised only to the first power. Okay, so cosine cubed x, well, that's really equal to cosine x times cosine squared x. So now already this part's okay, right? That's good. But we can't have cosine squared. So let's write this as, get my pen, cosine squared x is, so this is cosine x, I gotta think now. This is 1 minus sine squared x. It doesn't really help us. I guess, what we could do is just write it as cosine times cosine, but I don't think that's the point. Let's see, what double angles do we have? We know that sine 2x is 2 sine x cos x. we know that cos 2x is cosine squared x minus sine squared x. That's probably what I want to work with. And that's the same thing as 2 cosine squared x minus 1, right? So in order to get that, we're taking sine squared, and we're saying that's 1 minus cosine squared, which gives us this. So I'm going to take this, and I'm going to isolate for cosine squared x. All right, so let's back this up. That wasn't really what I wanted to do. That wasn't a good idea. So if I take this expression and I isolate for cosine squared x, right? That means that cosine squared x is equal to cos 2x plus 1 all over 2. And so I'm just going to put that in here. That's cos 2x plus 1 all over 2. Okay? And now we've met sort of what the question asked for. Function values of x are 2x, raised only to the first power. So this is raised to the first power. This is raised to the first power. And I think the instructions aren't written too well because many of you guys were thinking it before I was. Really an easier answer. Let's do that again. That's the answer. An easier answer that doesn't use any trig identities, but is smart, is you could just say, oh, well, this is equal to cos x times cos x times cos x. But that's supposed to be a smiley face there. But I think that's not what we really want. We want you guys working with the identities, so it's probably better to say cos cubed x is equal to cos x times cos 2x plus 1 over 2. All right. Oh, and they have answers here. Okay. Well, as you can see, we got some different things. I would ignore this because this is not secant. That's sine, so don't look at this answer. That's not what we want. And do we have the same thing here? Yeah, right. Because this is essentially what we have. All right. Good. That's basically the end of the video, except for pointing out you're going to have a lot of practice, guys. Okay, a lot. So we'll give you this. We'll give you this. We'll give you this. We will give you this. But it's not going to be on Moodle. It's not going to be in Lorna Faber's folder. So I'm just going to cross this out. It'll be through Classroom since we are doing e-learning. Okay? Tons of practice. Guys, you're through new content now. Wow. Through new content for the year. So congratulations on that. Please check the review. Please email your teachers if you're having questions. I'm crossing this out too. And I just realized that some of this is double, so I know you guys are enjoying watching and hearing me do this. I just want to eliminate stuff. So packet, yeah, 0707. And inverse trig worksheet and answers. Yeah, so we'll put all that stuff up. One more thing, and then we'll end, okay? This is the minimum you're supposed to do for homework. I would highly recommend that you guys work through this practice because, you know, this is the toughest unit, and we want you to be ready to go for whatever class you're going into next year. All right, so enjoy the trig. Embrace the, yeah, I guess I'll say it, embrace the difficulty. I was going to use a different word, but This is why you guys are in honors too. It's because this stuff is tricky, but we know that you can handle it. And so good luck with it. Be in touch soon.